All right, this is chapter 11, section 2. We're doing area of a circle. Area of circles and sectors. For this lesson, you guys will have a quiz on Tuesday. It's going to cover 11.2 and 11.3. So please, please, please make sure you're paying attention because it's going to go by quick. And then you have your last chapter test. And again, one test will be dropped. So definitely pay attention. All right, area of a circle. You have to know the formula for area of a circle. Area equals pi r squared. R being your radius. If you don't know what your radius is, it's the halfway point to any side of the circle. There could be multiple radiuses in your circle, radii in your circle. So you have to know which is your radius. Okay, you're only using one. So pi r squared, you're squaring your radius. All right, sector of a circle. What you need to know is what a sector is. We kind of covered this briefly in chapter 10 at the beginning when we were labeling the vocabulary. But your sector of a circle is the region bound by two radii and their intercepted arc of the circle. So what is it? I'm going to highlight it. This blue section or the orange section from before, this entire thing is the sector of the circle. Okay, if you want to know, it is like a piece of a pizza, piece of a pie, whatever you want to call it, but it's literally the entire piece of the circle. It's not just the arc measure, it's not just the radius, it's the entire measurement inside. It's the entire thing. All right, area of a sector. There is a formula that you have to know when you're finding the area of the sector. Okay, so area of the sector, formula for it is, please write it down. I have sector, area of sector. Formula for this is going to be the measure of the arc, whatever arc they're giving you, over 360 times pi r squared, which is just the area of the circle. Okay, so you need to find the measure of the arc, and I'll highlight what all of these information is. The measure of your arc is this measure right here. And then the measure of your radius is whatever radius measure they're giving you. They could be giving you one measure of the radius, they can be giving you both, but remember, it's only one radii. You don't need both, you only need one. All right, example number 1. These are pretty easy. It's just going to get harder as we go. And the last one is pretty challenging, so we need you to pay attention. This question says, find the area of a circle with a radius of 4.5 meters. Then it says, leave answer in terms of pi. Most of these questions you have to leave in terms of pi. What does that mean? I do not believe you will be getting a calculator. As of right now, you are not getting a calculator for this. And I'm going to show you how to leave it in terms of pi. Okay, that means pi is left over. You don't have to evaluate it inside your answer. So a couple things I need to know before I solve it. What are they asking me for? Area of a circle. So I have to know that formula. Area equals pi r squared. And they're giving me my radius, which is 4.5. Let me not use that. So this is going to go in for my r. So they're asking me to find my area. How am I solving it? Please pay attention to how I'm plugging it in. Area equals pi times 4.5 squared. Okay, so what did I plug in? I'm plugging in that 4.5 from what they gave me. Now I have to solve it. Again, you are not getting a calculator. So 4.5 squared is multiplying which two numbers? Does anybody know? What is 4.5 squared? How would I solve that? Good. 4.5 times 4.5. So I'm just going to go ahead and multiply it to the side. If you don't know how to multiply, please pay attention. It is 4.5 times 4.5. So multiplying it out, 5 times 5 is 25. 5 times 4 is 20 plus 2 is 22. Keep my place. 4 times 5 is 20. My 2 is already there. 4 times 4 is 16. Plus 2 gives me 18. Adding everything, 5 to 20. Because I have 2 digits to the right of my decimal, my answer also must have 2 digits to the right of my decimal. So right now, what do I have? I have A equals pi times 20.25 meters squared. But because I have that, because I have a symbol or a variable, I want to put it at the end. So my answer for this one is going to be area equals, I'm going to write it over here, area equals 20.25 pi meters. And that would be my answer. All right, the next one. Find the radius of a circle with an area of 176.7 square feet. So first of all, what I have to find is what are they asking me for? They're specifically asking me for my radius. I have to find my radius of a circle with the area as 176.7. So look at how I'm setting it up. 176.7 equals pi r squared. Now looking at it, how do I solve for my radius? What do I have to do first? Okay, I'm trying to get r by itself. What should I get rid of? The pi. I have to get rid of the pi first because it's pi times r. How do I get rid of the pi? Divide by pi on both sides. So now I have 176.7 over pi equals radius squared. How do I get rid of that squared? Good, square root it. So now I have 176.7, and that's all squared, square rooted. Can I have a square root as my denominator? No, I cannot. So I have to get rid of it. How am I getting rid of it? I need to multiply top and bottom by radical pi. These are going to cancel out. And then I'm going to get my answer left over. My radius equals 176.7 pi over pi. And I'm done. Questions, comments, concerns? Yes.
Are we ever going to need to multiply by like 2.04 or no?
If it says in terms of pi, you just leave pi. You just evaluate it with pi there. If it says rounds to the nearest decimal, I would then give you guys a calculator because that you would have to use the actual number, not round, because then it will change everybody's answers depending on what you round to.
Is that included?
For now, no, because I don't believe you're using calculators for this. So I would leave it like this. I wouldn't evaluate the pi. All right, for this one, just stop. Put your pens, put your pencils down. I'm going to do A and B, and I'm going to solve it. I need you to pay attention to this, and then I will give you time to solve, to write them down on your own. So far it's worked great. Everyone was able to do C and D by themselves, so I need you guys to stop and pay attention for a second. So for this, it's asking for the area of the sector. Okay, area of the sector, so you have to know that formula. Okay, formula for that is the measure of your arc over 360 times pi r squared. Again, I will give you guys time to write these down, so don't worry about writing it down. So reading the question, it says, the radius of a circle is 3 centimeters. So they will be giving you some sort of information, and they're giving me my radius. Find the area of the sectors determined by the given arc. So the arcs, they're giving to me. Okay, all the measurements here, A, B, C, and D, are my arcs. That's what I'm plugging in for arc. And then it says leave your answer in terms of pi, so I don't need a calculator. So I'm going to do A and B. Do not write anything down. Just look at the board and pay attention. First thing is I'm going to plug in. What am I plugging in? I'm plugging in this 50 over 360 times pi times my radius squared. Again, I just plugged in. Pay attention, do not write it down. Look at how I'm solving it. Whenever you're dividing and they both end in a 0, you could just cancel those zeros out. So now look at what I have. I have 5 over 36 times pi. Then I'm going to evaluate 3 squared, which is 9. Think of my pi times 9 as a whole number. How do I change it to a fraction? How do I change a whole number to a fraction? You put it over 1. So I'm going to kind of squish it together. And I'm going to show you what I have now. I'm going to have 5 pi times 9 over 36. Can I simplify any of these? Good. I could simplify my 9 and my 36 to 1 and 4. Now, look at my numerators. I have 5 times pi times 1. Do I need that 1? No, I'm going to have 5 pi. And then my denominator is going to be 4. And I have centimeters squared, and I'm done. I did not do anything else. Nothing too complicated, hopefully. I solved it in terms of pi. I'm going to do B. Don't write anything down. I'm going to give you time to write it down. Follow along. See if you can kind of do it in your head as I'm solving it. So looking at B, doing the same thing, I'm going to take that 20 over 360 times pi times my radius squared. They both end in a 0, so I'm going to cancel it out. Now I have 2 over 360, or 36, times pi times 9. Again, I'm going to put it over 1, and I'm going to squish them together. 2 pi 9 over 36. Because I did 9 and 36 before, and it gives me a 1, I'm going to use that. But if you did 2 and you're 36, just make sure you simplify it all the way. So looking at this one, I'm going to have 1 over 4. I'm going to then get 2 pi over 4. Can I still simplify this? Yeah. To 1 over 2. And then my answer is going to be pi over 2 centimeters squared. Okay, just think about it, look at it. Any questions on these two? Questions, comments, concerns, because you're going to do C and D by yourself. Yes?
On B, you lost me on the 1 over 4 when you simplified the 9 and 6.
Say it one more time for me.
For the 1 and 4.
Say it again.
For the 1 and 4 on B.
Uh-huh. Right here.
Yes.
9 goes into 36. So 9 goes into 9 once. 9 goes into 36 4 times. It's like simplifying your fraction.
Yep.
Okay, then I got 2 over 4. Then I could simplify those two. Any more questions on these? All right, go ahead and copy it down and try C and D on your own. All right, checking your work for the last two. Please check your work. So far, I feel like everybody got it. You have 140 over 360 times pi times your radius, which they told us was 3 squared. Because they both end in a 0, I'm going to cross it out. You're going to get 14 over 36 pi times 9. You can simplify your 9 and your 36. You're going to get 14 pi over 4. And some of you guys stopped here, but just know they're both even numbers, so you could simplify this. 7 and 2, and your answer is going to be 7 pi over 2 centimeters squared. Okay, this is for C. For D, looking at D, you have 210 over 360 times pi 3 squared. Because they both end in 0, you can cross them out. You're going to get 21 over 36. Then you have your pi times 9. You can simplify this to 1 and 4. And then this is your answer. 21 pi over 4 centimeters squared, and you're done. All right, last slide. Any questions on these? Did anybody have any trouble? I feel like we all understood this one. Okay, last slide. All right, this, you have to know information from previous chapters. So this is going to seem a little complicated. So far, a lot of them said it was easy, but it's a lot of work because this is work that you guys have already done and you've already been tested on this work. So just understanding what the question's asking. It says find the area of the region bound by, so I'm going to highlight segment AB and arc AB. So this is what we're trying to find. However, this is not what we've been doing. We've been solving for this entire area here. Okay, we haven't just been solving for a piece of it. So in order for me to find that shaded area, I have to do some subtraction. What do I have to subtract? I'm taking the entire sector area. So what I highlighted in blue. So I'm taking my sector area. Okay, area of a sector. And then I'm subtracting it from the area of a triangle. So if you don't remember the formula for area of a triangle, it's going to be a little difficult. And how to find the area of a triangle is also going to be a little difficult. So I have to subtract it in order to find my green piece. So first, let me find the area of my triangle. Okay, first thing I have to know is what is the formula for area of a triangle. Does anybody remember that? Base times height divided by 2. And looking at my triangle, when you're finding your base and your height of your triangle, your base, when you're finding your base and your height, this is your height, this is your base. Keep in mind for a triangle, it has to be the 90-degree angle. Okay, so looking at this triangle, are they giving me a perpendicular line? No. So I need to try and find it first. Looking at this question, I'm going to draw my perpendicular line. And because this is an isosceles triangle, these two angles are going to be the same measure. So how would I find these two angles? I'm going to do 180 minus 120. And I'm going to get what? I'm going to get my 60 divided by 2. Each of these angles is 30 degrees. Again, if I'm cutting in half, what's half of 120? So I have 60 here and 60 here, and then these are perpendicular lines. So what kind of triangle is this? We covered this in one of the chapters. Good. This is a special right triangle, which is that 30, 60, 90 triangle. Now, because I have that, yes, this is a special right triangle. You do have to remember, opposite of 30 is A, 2A, A radical 3. Are they giving me any measures? Yes. They're giving me this 6 right here, which is this side. So what should my A equal?
6.
Not 6. 3. Okay, 2 times 3 is 6. So this is 3 radical 3. Where did I get what 2?
Because that's the measurement.
2A, where did I get that?
Oh.
That's the rule for special right triangle.
A was, never mind.
Okay. All right, now looking at it, I need to find my base and my height. My base and my height, what is my base? My base is 3, and my height is 3 radical 3. If I multiply these, well, what I got? 9 radical 3. I am not dividing it by 2. Why am I not dividing it by 2? Because I have two triangles. I have this triangle here and this triangle here. If I divide it by 2, then I multiply it by 2, these are just going to cancel out. So my area for that triangle highlighted in yellow, my area is going to be, or in orange, 9 radical 3. Now I have to find my area of the sector. And we just solved those in the previous slide. So that I'm plugging in my arc. my blue arc right here is going to be the same measure as this in blue, this angle in blue, which is 120. So I'm going to take my 120 over 360 times pi. What's my radius?
60?
Good. It's not 60, it's just 6. And I'm squaring it. So same thing as we've been solving. Go ahead, you're going to cancel out your zeros. Right now I have 12 pi. What's 6 times 6?
36.
36 over 36. Can I simplify anything here?
12 pi.
Good. My answer would be 12 pi because these are both going to be 1. So I have 12 pi minus, don't forget this part, 9 radical 3. Can I combine anything or solve anything else? No, I'm done. This is my answer. So it is a lot of work, but it's work you've done before.